So let's just move on further towards a new topic, which is nothing but all about the graphical representation of the cumulative frequency distribution. So now we will represent the cumulative frequency distribution into a graphical manner. So how we can do it? Let us suppose we are considering a particular example in which we have the data of the marks obtained by a class in a particular subject. So this is nothing but of this form. As you can see, we have the marks obtained as less than 10, less than 20, less than 30, and so goes on, and with respect to their frequencies as 5, 3, 4, 3, and so goes on. So this cumulative frequency distribution is actually called as a frequency distribution of less than type, because you can see over here the marks obtained are into the formation of a less than. So now we will plot the cumulative frequency distribution into the graphical manner. But before that, let us suppose if I'm just writing out the cumulative frequency of this particular distribution. So first of all, 5 would remain as it is, so this would be 5, and again the next cumulative frequency for the less than case would be of the type 5 plus 3, which is nothing but 8, 8 plus 4, which is nothing but 12, further 12 plus 3 is nothing but 15, 15 plus 3 is nothing but 18, 18 plus 4 is nothing but 22, further we have 22 plus of 7, which is nothing but is equal to 29, 29 plus of 9 is nothing but is equal to 38, further we have 38 plus of 7 is nothing but is equal to, this is nothing but 45, and further we have 45 plus of 8, which is nothing but is equal to 53. So these are actually their respective cumulative frequency. So if we just wanted to plot the cumulative frequency distribution of the less than type case, we just have to take the two x-axes, obviously the x-axis and the y-axis, and on the x-axis we have to plot the upper limits. So here this is really very important case in which we have to plot the points on a particular graphical representation, or on the x-axis and the y-axis, in such a way that the x coordinates would be of the type of upper limits and the y coordinates are nothing but their cumulative frequencies. So for an instance, if I'm talking about plotting this representation on the graph, so first of all I'm taking the graph as of this form. So first of all, neglect this curve. So we have this x-axis, we have this y-axis, we are just taking the upper limits. As you can see, the upper limits are nothing but this, that is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100, and their cumulative frequencies are nothing but 5, 8, 12 and so goes on. So first of all, we are representing the upper limits on the x-axis, as you can see over here, and the cumulative frequency on the y-axis. So this is my cumulative frequency on the y-axis. So I'm just taking a 10-10 gap along the y-axis, and now further I'm starting plotting all these points on this particular coordinate axis. So first of all, the very first coordinate, as you can see over here, is nothing but of the form, the coordinates are of the form as upper limits, comma, the cumulative frequency. The coordinates that we have to plot on this particular axis or on this particular xy plane is of the type of upper limits, comma, cumulative frequency. So as you can see over here, the upper limit over here is nothing but 10 and the cumulative frequency is nothing but 5. So the very first coordinate is nothing but of the type 10, 5. The next one is nothing but of the type 20, 20, 8. So this is 20, 8. The next one is 30, 12. The next one is nothing but 40, 15. I hope you can easily see that how I'm writing all these coordinates over here using the formation of upper limits, comma, cumulative frequency, where the x coordinate is nothing but the upper limits and the y coordinate is nothing but the cumulative frequency. And now further I can see over here the next one is 50, 18 and so goes on. So let's just plot all these points on this particular plane. So first of all, if I'm just starting with 10, 5, so this is nothing but my 10, 5. Further, this point is representing 20, 8. This point is representing 30, 12, and so goes on till the last point, which is nothing but 100 comma 53, as you can see. So when I am just joining all these points with the free hand, as you can see, I'm just joining all these points with the free hand, the curve we get is nothing but called as a less than ogive, and we can also call it as nothing but a cumulative frequency curve of less than type. It is actually of the precise type, which is less than type, because of the reason you can see over here that the marks obtained that is given to us is nothing but of the form less than type. So always remember that whenever we just have to represent the cumulative frequency distribution of less than type, then in that case we have to take the coordinates into the formation of upper limits comma cumulative frequency, and the cumulative frequency we have to find in such a manner. So always remember the upper limits are on the x-axis, the cumulative frequency on the y-axis, and the coordinates would be of the type upper limits comma cumulative frequency. And after joining all these points or all these coordinates with the free hand, we get a particular curve which is nothing but called as the cumulative frequency curve, and especially it is called as a less than ogive. We can call it as a less than ogive, and we can also call it as nothing but a cumulative frequency curve. So this is nothing but a graphical representation of cumulative frequency distribution of less than type. Now let's just move on further for the more than type. Now let us suppose if we are just taking an example of more than type. So as you can see over here, the marks obtained by the number of the students in a class is nothing but of the type more than or equal to 0, more than or equal to 10, more than or equal to 20, and so goes on. So for them we have to find the cumulative frequency. So this is actually the question which is of the same type that we have taken for the less than type. So over there the sum of all the frequencies is nothing but 53. So for this case, for more than type case, we have to find the cumulative frequency in such a manner. Means we have to start with the sum of all the frequencies as nothing but 53, and then we have to subtract the respective frequencies in such a manner. So as you can see over here, if you'll compare this question with the previous one, you can see over here that for the very first case, whenever we have the more than type of a question, then in that case we have to find the cumulative frequency in such a manner that for the first case we have to take the sum of the frequencies as nothing but 53, and for the previous case we know that for the less than type of the case we have the very first term which is less than 10, and for that we have the frequency as nothing but 5. Now for the more than case, we are taking more than or equal to 10. So more than or equal to 10 would be of the type 53 minus of 5, where 5 was the respective frequency of the less than type case. So now 53 minus 5 is nothing but is equal to 48. Now further we have to subtract the respective frequencies again. So 48 minus of 3, which is nothing but is equal to 45. Further we have to take 45, we have to carry forward 45 further again. 45 minus 4 is equal to 41. Further we have to carry forward 41 again. 41 minus of 3 is equal to 38, and so goes on till the last term which is 15 minus of 7, which is nothing but is equal to 8. Now in order to plot the cumulative frequency distribution in the xy plane, first of all we have to take the lower limits over here, the lower limits. For the less than case we always take the upper limits. For the more than case we always take the lower limits with respect to their cumulative frequencies. So let us suppose if we are just taking the lower limits and the cumulative frequency on the x-axis and on the y-axis in such a manner. So first of all, just neglect the curve, just neglect this curve. First of all, you can see over here, I'm just taking the lower limits on the x-axis, I'm just taking the cumulative frequency on the y-axis, and now the coordinates would be of the type lower limits comma, the coordinates of the type lower limits comma, the cumulative frequency, means the respective cumulative frequency. So as you can see over here, the very first coordinate would be of the type, this is nothing but their lower limit, that is 0. 0 is nothing but their lower limit. So the very first coordinate would be of the type 0, 53. This is 0, 53, and the next one is nothing but 10, 48, because 10 is nothing but their lower limit. Now further move on to 20, 45, 30, 41, and so goes on on till 90, of 8. So let's just plot all these coordinates. So if we are just plotting all these points in this xy plane, you can see this is nothing but the point which is representing 0, 53. This is representing 0, 53. This is actually representing 10, 48. This is representing 10, 48. And so goes on. This particular point is representing 90, of 8. So when we are joining all these points with the free hand, so I'm just joining them with the free hand, we are getting such kind of a curve, and this is nothing but called as again the cumulative frequency curve, which is also called as nothing but a more than ogive, because this is nothing but the case of a more than type. So that's why called as a more than ogive. So let us suppose if I'll just write it over here, we can also call it as nothing but a cumulative frequency curve. Cumulative frequency curve of more than type. This is nothing but called as a cumulative frequency curve of more than type, and we also can call it as nothing but a more than ogive. We can also call it as nothing but a more than ogive. So this is all about the representation of cumulative frequency distribution when we have a special case of more than type. Now let's just talk about finding out the median. So we know that if we just wanted to find out the median, we just have to take the very first step in which we have to find the value of n by 2. So let us suppose if I'm just taking a curve which is nothing but a type of upper limits, means a less than type of ogive curve. So let us suppose if I'm just taking the less than type of ogive curve. So first of all, neglect all these things. So we have this less than ogive curve. So if I just wanted to find out the median for this particular cumulative frequency distribution, or for this particular question, how we can find it? So first of all, we know that the very first step would be like we have to find out the value of n by 2. So we know that the sum of all the frequencies are representing n, and the value of this was nothing but 53. So 53 by 2 is nothing but is equal to 26.5. Obviously this is 26.5. So we'll take this 26.5 as nothing but a y value, a y coordinate. So as you can see, let us suppose if I'm just taking this point as 26.5, and if I will draw this particular line to this less than type curve, and such that it should be perpendicular to it, should be perpendicular to this particular y-axis. So let us suppose if I'm just joining a straight line to this particular curve, wherever it is intersecting, from that point of intersection, if I'm just drawing a perpendicular onto the x-axis, if I'm just drawing perpendicular to the x-axis, wherever it cuts the x-axis, that particular point would be called as nothing but the median, and hence that median is coming out to be is equal to 66.4. So through this graphical representation of the ogives, we can also able to find out the median. As you can see over here, whenever we just have to find out the median for such cases, we have to find the value of n by 2 first, and that n by 2 will exist as a value y. So on the y-axis we have to plot that particular value, that is 26.5, and from that particular value we have to draw a perpendicular to the curve, and after that, wherever that particular line intersect the curve, from that point of intersection A, we have to draw a perpendicular on the x-axis, and wherever that particular perpendicular is intersecting that x-axis, that point of intersection is nothing but called as the median, which is here coming out to be is equal to 66.4. So this is the case when we have a single ogive, So let us suppose if I'm just talking about if we have two ogives all together, means more than type and less than type together. So how we can able to find it? So let us suppose if I'm just taking a case of that, whenever we have the two ogives, that is more than ogive and a less than ogive, wherever these two ogives intersect each other, it will draw a perpendicular from that point of intersection. Wherever it is intersecting the x-axis, that point is nothing but called as the median. As you can see over here, the median is coming out to be 66.4, which is exactly same as that of this particular ogive, which is nothing but a case of less than ogive. So through this this particular method means with the help of the ogives, you can also able to find out the median in such a manner. So let us suppose if we just have a single ogive, we can find the median in that manner, or if we have the two ogives together, then we can find the median through their point of intersection, because after their point of intersection we just have to draw a perpendicular, and wherever that perpendicular intersects the x-axis, that point would be nothing but called as the median. So this is the way through which we can able to find out the median. Now let's just do some of the questions that are related with this concept.